Yeah, good afternoon to this session. Just wanted to check, are people there, the presenters? Can people, like the first paper, who will be the speaker? I think I see Monira.
Yes,
Will you
I'm
be
here.
you will be presenting?
Yes.
Okay. And the second paper, Amin, is he there? Okay, is he there? Yes, I see him. Hi, Amin. I am assuming you will be presenting. Am I right? I cannot hear you.
It's me, Amin Shraidi. I will present now or
No. I'm just checking. I'm just checking who will present. Okay. Yeah. Yeah, I'm just checking all the speakers. Okay. And the third paper, Fatima, is it?
Yes, I'm here.
Okay. That's good. So you will present the third paper, then the fourth paper, Adil. The fourth paper, the ID 95. Don't see anybody here. How about the fifth paper, Fadallah?
Yes, I am here.
You will present?
Yes.
Okay, good. So we just have the fourth speaker. I think will join. So okay. So again, good afternoon to all of you. I am DK Panda, and from Ohio State. I just gave the keynote talk in the previous session. Thanks to all of you for attending that talk. So we'll start this session titled High Performance Computing, and each paper is allocated 15 minutes presentations and 5 minutes question. So we'll start with the first one, titled High Performance Computing Under Availability Constraints to Solve Dense Triangular System, and co-authored by Monira Bellamar-Brock and Monir Maraksi, and it will be presented by Monira, right? And please feel free to share your slides. Are you doing live or are you doing a video, or what is the plan?
Live.
Live. Okay. So please feel free to share your screen, and if you can introduce yourself. I don't know more about you. You can introduce yourself and get started.
Okay. So I am Munira Belmabrouk from Tunisia. Okay.
Yeah.
I am PhD student from Tunisia. So my thanks, sir. So my work deals with high performance computing under availability constraint to solve dense triangular system. So for that, and during this presentation, in first time I present the two steps graph and I define the availability constraint. After that, I determine the problem and our goal. Then I present two parallel algorithms solving the triangular system, which is the critical path algorithm and the modified critical path algorithm, which will be studied later with availability constraints, theoretically and experimentally. Finally, I conclude and I indicate some prospects. So I start with presenting the two steps graph. The two steps graph is the precedence graph of the algorithm solving triangular system. Its vertices are the tasks with a constant cost, and its arcs represent the dependencies between tasks. I present now the availability constraint. So thanks to the grid and cloud computing, we can now distribute the execution of an application previously divided into tasks across processors which we probably do not know about their location and availability beforehand. On the other hand, it's possible to have maintenance requirements, breakdowns, and processors which are held by a sub-program with higher priority, or other constraints which make the machines not available for processing. In such environment, the number of processors varies in time. The problem of scheduling takes us from the classical model where all resources are available without interruption to a more realistic model in which we must take into account the resource constraints. This model has two possible configurations. The first one, when all informations are known in advance, which is the offline configuration, whereas the inverse is online configuration. Now I will present the problem and our goal. So, all efficiencies, scheduling, executing the two steps graph in a homogeneous environment are presented in classical model, like oriented column algorithm, P+ in distributed memory, and critical path algorithm plasma on shared memory. So our goal is finding an efficiency scheduling algorithm having the opportunity to add or remove some active processor, which is the availability constraints. For that, I will present the two algorithms, the critical path algorithm and the modified critical path algorithm. So the critical path of a task is formed by the tasks linking them to the final task. For example, this is the critical path of the task 2-4. The number of these tasks determine its length, which is here. The longest critical path is that of the first task T11. So, the critical path algorithm executes from the free tasks those having the higher length of critical path. And if two tasks having the same value, the choice became arbitrary. Therefore, in general, this algorithm starts at the time t equals 0 by executing task T1y with a single processor. However, the other processors are inactive as there is no other free task. Then, the critical path algorithm can be presented in two phases. At each iteration in phase 1, the critical path algorithm executes exactly 2p tasks, and this phase is present as follows. In the phase 2, the execution is done from one diagonal to another in this order. So on each step, the critical path executes P tasks. The modified critical path algorithm. So with the M identical processor, the modified critical path algorithm is derived from the critical path algorithm with the P processor, where M is lower or equal to P. In fact, modified critical path algorithm use the task order given by the critical path algorithm with P processor. So, the modified critical path algorithm and the critical path algorithm, the two parallel algorithms respect the precedence constraint and reach the optimal make space. In this section, I will explain the modified critical path algorithm with availability constraint. So, with offline setting, we define four availability constraint pattern: initial unavailable, final unavailable, traced unavailable, and traced availability. So in this, this is an example taken for the final unavailable. In fact, for in a matrix size 10, the task labeling with the critical path algorithm with P equal 3 processor. The modified critical path algorithm works with 3 processor until instant 4. So the 3 processors are available and works until instant 5. And from now, the third processor will be enabled, and only 2 processors works until the end of the execution of the graph. The final makespan is 27. This is the execution time of each pattern. Voilà. So the reduction or the add of processor has no sense when it's done in the third part of the graph, but when the add of processor is done in the second part of the graph, where the execution is done by diagonal, and when the number of tasks of this diagonal can't serve all available processors, so the value of the makespan will be equal to the length of its critical path. For that, we have second value of makespan for some patterns. Now I will expose some experimental results. So the different parallel scheduling presented are implemented in French grid computing the grid 4000, which is a parallel environment. The programming language used is C, language C with OpenMP library. We define the efficiency, which is the rate of activity of processor. We choose the metrics randomly for all our experimentation. So these curves represent the efficiency in function of processor number. In general, it should be noted that as the number of processors increases, the efficiency decreases, and this for any pattern which is explained by the increase of communication costs. We show also that the efficiency of final unavailable and traced availability is better than its inverse, which is initial unavailable and traced unavailability, because the period when there are fewer processors available is quite important compared to the total make space. Now I'll show the effect of CPU availability on efficiency. So in this figure, we leave all informations constant. So when the time t increases, the efficiency decreases for final unavailability. This is due to 2 reasons. Firstly, The cost of communication became large when the number of processors progresses, and secondly, at the end of the execution of the graph, the free times of processors increase with the number of processors and reciprocally. These figures represent the various of theoretical and experimental efficiencies of different patterns according to the time expressed in number of tasks. They show a certain adequacy because between results, the gaps that can be noted are due to the time required to call up tasks, to use the instruction and other elements of the parallel program, which are not taken into account in the theoretical formula as communication cost, synchronization. Finally, I will conclude and I will present some prospect works. So we have implemented 3 scheduling algorithms: the critical path algorithm, the modified critical path algorithm, and the modified critical path algorithm with the availability constraint using the OpenMP. And I experimented this algorithm on grid 3000, and we can in the future expand this study to other patterns, and we can study the problem of scheduling with limited processor availability as a problem in heterogeneous environment, where not like this, where our work is in homogeneous environment. Thank you. And any question?
Okay, thank you for your presentation. So, are there any questions in the audience? So I have one question. So I didn't catch it. So how many processes or nodes did you use for your experiment?
In our experimentals in grid 3000, we used cluster in RANS cluster, where we can have 44 cores.
44
in
cores.
One, yes.
So you used it on in one node, or did you take multiple nodes?
OpenMP with the same node, with the core in the same nodes.
Okay. So how
shared
do you
memory.
Yeah. I mean, some of the recent platforms, like if you see AMD Rome architecture, they have 128 cores within a node. How will your solutions fit there? Will it directly work, or do you need any changes, or? Can you hear me?
What?
What I was asking, you experimented with 44 cores. Some of the recent hardwares are trying to provide like a 128 cores for CPU. Yeah.
In which grid this? In grade 4000, it's the maximum. What you...
Okay. No, I know. I'm just saying whether your solution can work on other platforms.
Yes, it can. Okay. It's on OpenMP, so I can, but it can work on any parallel platform. Just I have permission to test that on grid. For that, I use this only this platform.
There is a question on chat. If you can take a look. Uh, Can you take a look at the question on the chat and then do you want me to read the question or you can read it? Can you hear me? Okay, I don't know. So might be we can move to the second talk and she can reply back in the in chat. So let's move to the second paper in the session. It is titled Runtime Optimization Using a Novel Implementation of Parallel PSO for Real World Applications. And it will be presented by Amin.
Hello.
Share your slides and then introduce yourself and then can present. Can you share your slide, Amin?
Hello. Can you hear me?
Yeah, can you make it a little bit louder? I can hear you, but you may need to
I will share the.
increase the volume a little bit.
Hello everybody, my name is Amin Shraibi. I am a PhD student at Hassan First University, Morocco. My research interests include cloud computing optimization algorithm. I am here today to present a paper entitled Runtime Optimization using a novel implementation of parallel PSO for real-world application. The table of contents of our presentation as follows: introduction, objectives, proposed work, results and discussion, conclusion. Introduction. On one hand, in computer science, optimization is the process to modify a function, a model, or a program in order to make some of its features work efficiently and also to use fewer
excuse me,
resources. It will
excuse me, I
generally
think your
focus
slides are
on
not moving.
improving aspects of performance such as memory usage, and disk space, power consumption, bandwidth, especially execution time, which our paper focuses on. The execution time is the time elapsed between the start and completion of a program. Research in software engineering mainly considered the reduction of execution time being the chief concern of processor architects and software developers. The reducing could be done by reducing the number of lines of code. The more the number of lines of code, the larger is the time taken. The processor frequency. The lower the frequency of the underlying hardware component, larger is the time taken for its execution. For the memory also affect the execution time. Reducing memory usage should be done to reduce the execution time. Parallel programming. Various parallel programming paradigms can be used to write parallel programs such as heterogeneous computing, which is used to accelerate a wide range of general purpose applications by exploiting their high performance many-core processor. OpenCL is one of those parallel paradigms that are designed to program heterogeneous parallel systems, including both multi-core CPU and GPU as example. In another hand, evolutionary algorithms are algorithms based on the iterative generation of potential solutions to a problem, called population, which evolves over time resulting in selection of the best solution, which is defined as an objective output. During the last 20 years, evolutionary field, but they lost their efficacy once applied to large problems like huge data amount optimization, and their implementation has been stressed using diverse configuration with growing dimensionality. The objective of our paper is the study and optimization algorithm and its execution time when dealing with large data. In our case is PSO, particle swarm optimization. Also propose an accelerated version of the chosen algorithm, PSO, which consists in using a parallel framework, OpenCL, to reduce its execution time. Particle swarm optimization is a stochastic optimization technique introduced by Kennedy and Eberhard in 1995. Inspired by social behavior of fish scuttling or bird flocking, its goal is to search the best solution of a problem. In the PSO algorithm, the population of the feasible potential solution of the optimization problem is often called a swarm. Feasible potential solutions are called particles. The main idea of PSO is initialized by generating a group of random particles and then search for the optimum in the problem space by updating generations. During all iteration, each particle is updated by two values: personal best, which is the best position achieved so far by a particle, and the global best, which is the best value obtained so far by any particle in the population. In each iteration, the particle updates its velocity and position with 1 and 2 equations. Based on parameters such W, as which is the inertia ways, the previous calculated velocity and position, C1, C2 are learning factors, R1 and R2 are random variables in the 0-1 interval. Open Computer Language is a framework suited for parallel programming of heterogeneous systems. OpenCL was released Hello
in
everybody, my name
2008
is
by the Kronos Group, and it supports multiple of devices such as CPUs, GPUs, DSPs, etc. The OpenCL development framework is made up of three principal components. The language specification specifies the syntax and program interface for writing kernel programs that run on the supported accelerator, multi-core CPU, GPU, or FPGA. The OpenCL programming language is based on ISO C99 specification with added restriction and extension. The platform API lets the developer use the notion of device context and work use to choose and initialize OpenCL device. Submit work to the runtime API uses
context for managing execution unit is composed of one or more system element. Process element executes and a single program executing multiple data or single action multiple data. The execution model includes two components. Kernels are the fundamental unit of the code that runs on OpenCL devices. Each execution of the kernel in index space is called a work item. Each work item executes the same kernel function but on different data. All work items relating to the same work group run in parallel. Well, different work groups can be scheduled in sequence based on the accessible resources. The host program. The host program is responsible for managing and setting up the execution of kernels of the OpenCL device by use of context. The memory model defines four regions of memory accessible to work items when executing a kernel: the host memory, the global memory of the device, and the local memory of each compute unit, a private memory for each work item. Proposed work. In figure, a new PSO implementation using OpenCL is proposed to reduce PSO execution time in significant dimensional data optimization. Each constant used by PSO is generated automatically by the host's code as a string and added to the header of loaded kernel as a preprocessor constant using defined keyword. This feature is used to avoid passing many parameters to OpenCL kernel and also to let the user specify the parameters. Variable initialization. Some of the PSO variables are two-dimensional, such as position and velocities. Moreover, OpenCL disallows passing down return two-dimensional arrays. To resolve that, we need to flat each two-dimensional array into one-dimensional array. Taking, for example, position matrix variable with 3 particles, each particle has a vector with the number of dimensions equal to 3. The figure shows the process. A is the position flattened matrix and B is the position matrix. Creating buffer. Each variable created and initialized need to be copied into device global memory. We specify the size in bytes of the buffer memory object to be allocated. Also, we specify a flag that informs OpenCL about the mode used by the kernel, read, writing, or both. The last step is the read best position and best from the memory. The device part consists of two kernels. The first kernel defines the calculation of the velocity and the position of each particle E and dimension G. The second kernel, the calculation reduces into one kernel dimension, which is the PSO particle, calculates fitness and presents the update of the best position and cost. In order to evaluate the implementation, we choose the PSO algorithm based on the standard PSO version 2006. We proposed the basic PSO parameter described in table. Number of particles is 100, number of dimensions in a particle vary from 200 to 2000 with step of 200. We vary only the dimension number of particles to generate more data and see the effect of execution time. We also choose to test our implementation on different devices such as GPU and CPU, whose some of their specifications are described in the table, such as max work items, device frequency, Grewonk function, and Alpine function. Four figures show the result of our implementation. The difference between sequential and OpenCL implementation in different devices. It also underlines the effect of changing device, objective function, and increasing particle dimension on execution time, and increasing particle dimension on execution time. The execution time also varies from device to another due to its specification, such as the number of cores, max work item, etc. In order to show the effectiveness of our results, both sequential and parallel implementation were established in an enormous dimension and with more extended period. We choose only one OpenCL device, which is Intel Core i7 CPU, for the parallel execution, and one benchmark function, which is the sphere function. We also increased the dimension starting from our previous result, which is 2000, and then began from 10,000 until 100,000 using a step of 10,000. The figure shows the comparison results. The experimental result analysis. According to our implementation results, we concluded the following. First, the parallel PSO provides a good and significant improvement in the execution time compared to the sequential PSO implementation. Second, in the comparison between every implemented device, the execution time varies from device to another due to its specification, such as clock speed. The Node SPU currently has a significant lead over GPUs in clock speed. The clock speed lowest value of the most CPU is 2 GHz, while the clock speed highest value in GPU is 1 GHz this day. This factor helped the CPU win over the GPU for small workloads. Cores numbers. GPU have a large number of cores compared to CPUs, which means that CPUs can execute more work items in parallel than CPU. Global memory. Whenever the amount of global memory is bigger, the capacity of holding and treating more data is higher. The max works item. Each group of items is limited by a predefined number, which is the max of work item and which does not limit the global work item size. This limit can affect the synchronization between work items of each group, which means the more significant is the capacity, the more work items can be synchronized. Church increasing the dimension for 10,000 to 100,000 shows the effectiveness of extended data. Even if the amount of time needed to execute both sequential and the parallel implementation increased linearly, the second one still less than the first one. For example, in dimension 20,000, the sequential implementation takes 12 seconds, but the parallel takes only 1 second. So the parallel implementation can achieve up to 7 times acceleration compared with the sequential one. With 100,000 as an end dimension, the sequential implementation takes 62 seconds, while the parallel takes only 6 seconds for a 9 times acceleration difference. This means that when the dimension increases, the acceleration increases also. In this work, we proposed another implementation to solve the problem of an algorithm that requires a considerable execution time when it comes to extensive data such as PSO. We also underlined the effectiveness of integrating OpenCL to reduce the execution time of the algorithm. The results show that the PSO OpenCL implementation is faster than the sequential PSO implementation when we increase the number of dimensions. The effect of running OpenCL application in various OpenCL devices has been highlighted in this work. We use PSO in many real-world applications such as scheduling issues, especially in a cloud computing environment, which in the future allows and encourage us to work on more implementation, not only in GPU and CPU device, but also on FPGA. Thank you for your attention.
Thank you. Are there any questions?
Sorry for the technical issues.
I can't hear you. Can you please be a little bit louder?
Sorry for the technical issues for the video. It's stuck on the first slide.
Yeah, that's correct. Yeah, but anyway, you finished it. So I didn't catch the. What are your future work? What is the next step you will try to?
My next work is to use the OpenCL implementation in the task scheduling in the cloud computing using PSO, the same algorithm that we use in this paper. We will improve it in the task scheduling. That's our future work.
Any other questions? Either you can post it on the chat or you can directly ask the question live.
Can you repeat, please?
No, no, I'm asking everybody if
Ah.
if there is any question. Okay. Okay, so if not, thank you. We'll move on to the third paper in the session. It is titled Evaluation of NDVI and NDWI parameters in CPU GPU heterogeneous platforms based CUDA, and it will be presented by Fatima. Is that correct?
Yes, yes, I'm here.
Okay. So would you like? So are you presenting live or a video?
No, a live
Okay.
presentation.
So please share your slides and then get started. You can introduce yourself a little bit and then get started.
Yes. Good afternoon, everyone. My name is Fatima Zahra Garouj from Morocco. I am a PhD student at the LISI laboratory at the INSA Agadir, Morocco. So today I would like to present our work entitled Evaluation of NDVI and NDWI parameters in CPU GPU heterogeneous platforms based CUDA. In this presentation, we will follow the plan as follows, starting with an introduction, followed by the objective, then present the most used vegetation indices NDVI and NDWI. After mentioning the heterogeneous systems, then present the proposed architecture in order to evaluate the vegetation used, the results obtained in this work, and finally, a conclusion. In our days, food requirements in terms of supply and quality are more and more demanding. Farmers have expressed the need for a radical technological advance that will increase productivity, ensure that food quality is compatible with ever-expanding food regulation, and further reduce costs, where precision agriculture is a farming management system that seeks to use new technologies at every stage of work. In addition, precision farming aims to improve accuracy and increase crop yields and profitability while lowering the levels of traditional inputs needed to grow crops such as land, water, fertilizer, herbicides, and insecticides. So through the development of technologies such as GPU, graphic processing units, DBN, deep belief networks, and the rapid development of artificial intelligence, the capacity of computer vision technology has been greatly enhanced, and improvements in research efficiency have provided many decision-making and practical insights for farmers, thus ensuring the efficiency of agricultural production. The objective of our work are to target heterogeneous architectures such as Jigsaw TX1, CPU GPU in the field of precision farming, perform a parallel implementation using CUDA to optimize execution time, and an efficient implementation of vegetation and this is merging two or more of them into a single GPU execution. Uh, the vegetation indices are widely used, on the one hand, to identify and monitor vegetation dynamics, but also to estimate certain biophysical parameters characteristic of the vegetation cover, such as biomass, leaf area index, vegetation fraction, and active photosynthetic radiation. In addition, vegetation indices derived from Earth observation satellites or from drones are important for a wide variety of applications, such as vegetation monitoring, drought studies, agricultural activities, climate, and hydrological modeling. Our work focuses on two of the most commonly used vegetation indices, NDVI and NDWI. For the NDVI, or Normalized Difference Vegetation Index, is constructed from the red and near-infrared channels. The Normalized Difference Vegetation Index highlights the difference between the visible red and the near-infrared bands, as shown in the equation below. NDVI values range from -1 to +1, where the values approaching to 1 indicate good vegetation condition, whereas the NDWI is a remote sensing-based indicator sensitive to the change in the water content of leaves. NDWI is computed using the near-infrared and the short-wave infrared SWIR reflectance or the green band. The NDWI product is dimensionless and varies between -1 to +1, depending on the leaf water content, but also on the vegetation type and cover. High values of NDWI in blue correspond to high vegetation water content and to high vegetation fraction cover. Low NDWI in red correspond to low vegetation water content and low vegetation fraction cover. The normalized difference water index (NDWI) is known to be strongly related to the plant water content. It is therefore a very good proxy for plant water stress. Today, general purpose computing on graphic processing units (GPGPUs) has recently emerged as a powerful computing paradigm to the massive parallelism provided by several hundred processing cores. This has led many researchers to choose parallel platforms for their treatment. The GPU is often used for co-processing to accelerate the processor used in a computer for engineering purposes, due to the large number of graphic cores organized in multiprocessors that are equipped with it. For the heterogeneous system, a system is called a heterogeneous system if it is composed of several different processors, including CPU, GPU such as NVIDIA Jetson TX1 or Android Xeo4, and CPU FPGA such as DE1 SoC and CPU DSP. As the CPU and GPU are used in a wide range of applications, it has been recognized that these two processing units have unique characteristics and assists, and therefore CPU-GPU collaboration is inevitable to achieve high-performance computing. As a part of the GP-GPU concept, NVIDIA Hello?
Hello, we cannot see anything on the slides. I think it got disconnected.
Uh,
Can you please share the slides again? Yes.
the slide of Huda?
Yes, now things are good. Please continue.
Okay. As a part of the GP-GPU concept, NVIDIA has developed a C-based programming module.
No, it went away again.
We have a connection problem. So as a part of the GPU concept, NVIDIA has developed a C-based programming model, Compute Unified Device Architecture CUDA, which offers greater programmability for high-performance graphic devices. In fact, general-purpose computing on graphic devices with CUDA enables performance improvements for many applications under the concept of a single instruction multiple thread. The CUDA architecture provides a grid which composed of associated block. These blocks are constituted of the thread. The thread is an instantiation of the kernel. The CUDA program contains the host code and the device code. The host code controls the execution of the device code as well as the communication between host memory and device memory. The CPU memory and the GPU memory are distinct, so the communication between them is then assured via PCI Express. For our work, the proposed algorithm is separated into 4 blocks. The first block aims to acquire images. In our work, we used a dataset that contains RGB and near images of sugar beet crop. Subsequently, the second block is the pre-processing phase, which provides a test to check the number of the bands in the image. If the image contains all bands, it is necessary to separate them to the bands red, green, and blue. Otherwise, the conversion step starts to convert images to grayscale and in double precision. Hello, do you hear me?
Yes, we can hear you.
Sorry for the problem. So otherwise, the conversion step starts to convert images to grayscale and in double precision respectively. Afterward, the third block is the core of the algorithm, which processes both NDVI and NDWI indices simultaneously. When the CPU completes its process, it starts transferring data from its memory to the GPU memory. This transfer is done via the PCI Express communication bus. Then the GPU starts calculating the NDVI and NDWI vegetation indices. This calculation is done in the thread of the GPU block in a parallel way. After the calculation of NDVI and NDWI, the GPU transfers the result to the CPU via the PCI Express. And finally, the last block is based on a thresholding operation to make decisions and store the resulting images. In our work, we used the TX1, NVIDIA JSON TX1 to implement our algorithm. The NVIDIA JSON TX1 is comprised of 4 ARM 64 bytes Cortex A57 CPU cores.
Yeah, we lost you. So please share the slides again. Yeah, it looks good now. We can see your slides, but we cannot hear you.
Now, do you hear me?
Yes, yes, we can hear you now.
Hello? As I said, the NVIDIA JSON TX1 comprised of 4 ARM 64 bytes Cortex A57 CPU cores with a max frequency of 1.91 GHz and has a 4 GB of LPDDR4 memory with 25.6 GB per second of memory bandwidth. and has a 256 core Maxwell graphic processor. There is a 16 gigabyte of storage on board, as well as a SSD slot for expanded storage. We also implement our algorithm on the Dell laptop, which comprised of 384 core of the GPU GT 920M, and on the Odroid X04, which has a GPU of type ARM Mali. For the results, the heterogeneous CPU-GPU architecture is taken into account in our work due to its popularity in embedded computing platforms, and we evaluate the average processing times of the algorithm on 80 image with a resolution of 1296 966 pixels. By allowing the processing to the GPU, the algorithm on a Dell laptop works at 50 milliseconds per image, which means 20 images per second. Also on the TX1 embedded platform, the algorithm operates at 80 milliseconds per image, which provides 12 images per second. However, on TXU4 card provides 10 frames per second with an algorithm execution time of 91 milliseconds. Then, with the GPU implementation on the Dell desktop, we have a better performance. Dell laptop, we have a better performance in which the average execution time of the algorithm is reduced on 0.063 milliseconds per image, while for TX1 the processing is slower than the Dell laptop. The algorithm takes an average of 0.77 milliseconds, and on the X04 the algorithm takes an average of 0.82. Experience shows that the high-end NVIDIA GeForce on the Dell laptop achieves a speed 7 times faster than the X1 GPU due to the higher CPU and GPU frequency, multi-core integrity, and large cache memory. Moreover, using the GPU architecture for tasks requiring intensive data performs more efficiently than CPU thanks to parallel computing. So the main contribution of this work is the integration of embedded systems in the agricultural field, where embedded systems are allowed to respond to the needs of efficient speed and memory use. In addition, embedded system cards are smaller in size and lower in weight, offering a lower power, which makes them portable on drones and agricultural robots. Finally, the precision agriculture, with the help of embedded systems, become more efficient, intelligent, and steady. In our contribution, we present an implementation that is more optimal in terms of execution time in a heterogeneous CPU-GPU architecture. The results show an effective speed up for heterogeneous CPU-GPU systems compared to homogeneous CPU systems. And then the Jetson TX1 embedded card offers lower cost, lower power, and small size, making it portable to UAV and robots. Thank you for your attention.
Thanks for your presentation. Excuse me. Is there any question from the attendee? So I have a quick question. So these are good results. So what is your next step?
Our next step is to use more vegetation indexes, and use these vegetation indexes as a feature extraction for the machine learning or deep learning for to extract the disease of plants.
Okay. So there is a question on the chat. It says why you have not tested your approach using the OpenCL architecture via CPU GPU.
Because the GPU is more powerful, especially the GPUs of NVIDIA. is provides a more numbers of cores. So we used this NVIDIA Jetson TX1, which has a 256 core, provides provides more parallel implementation, and for the intensive computing.
Are there any other questions? So if not, thank you again. So we will move to the next paper in the session, the fourth paper. It is titled "Better Edges, Not Bigger Graphs: An Interaction-Driven Friending Algorithm for the Next Generation Social Networks." And is it being presented by Adil?
Yes, yeah, Adil Ash-Shamari.
Yes, yes. Hi. Please share your slides. Introduce yourself briefly.
And I don't think my connection would handle the video and audio. Can you use the video I sent?
Yeah, that can be done. Just introduce yourself, and I believe the video can be played.
Okay. Yeah. My name is Adil Ash-Shamari. I defended my PhD dissertation a year ago, and currently I'm an assistant professor at Northern Border University in Saudi Arabia.
Thank you. So might be the conference manager can play the video.
Hello everyone, my name is Adil Ash-Shamari. Today I'll be presenting our research, Better Edges, Not Bigger Graphs, an interaction-driven friending algorithm for the next generation social networks. Before I start, I'd like to thank the organizers of CloudTech and the reviewers for their valuable feedback, and I'd also like to thank you for taking the time to attend. I'll start off the presentation by talking briefly about recommender systems in general and some related work. And I'll talk more about friending recommender algorithms. We'll talk about some issues related to friending algorithms within existing social networks. Then I'll present our collected data sets. Then I'll move to our main approach, the interaction-driven friending algorithm. I'll present our findings and our experimental results. Recommender systems were first introduced in 1992. A recommender system is a decision-making system that filters results for users based on a variety of factors such as users' profiles, locations, history, etc. Very well-known companies like eBay, Amazon, and Netflix have built in their own recommender algorithms to filter a huge number of possible results and only display a set of personalized results that match the target user's preferences. A recommender system is also used to recommend friendship connections within social networks, like in Facebook and Twitter. In this research, recommending friendship connections is our main focus. Facebook is the largest social network, and Facebook's friending algorithm may suggest a number of connections over time between users, and although users may accept most of these recommendations, still the majority of these accepted friendship connections end up not leading to any interactions. We call these kind of connections in our research as weak connections. So interactions between friends within a social network is very important and can have a social as well as a business impact. A UK study stated that interactions with a diverse network of people are proven to be very beneficial to people's mental as well as physical health. Yet, the largest social network recommends only a small percentage of interactive friendship connections. When it comes to business, Clemens in his paper argues that active participations, which is one of the 4 Ps he suggested, and interactions are one of the keys for the success of a social network business. Another paper stated that forming a social network based on interaction graphs is key for a trustworthy and reliable social network. In our approach, we present a friending algorithm that recommends friendship connections that have a higher probability of leading to interactions than existing friending algorithms. Before I talk about friending algorithms, I should mention that there are 2 well-known recommender systems: the obvious content-based recommender algorithm and the collaborative filtering algorithm, which monitors users' activities, in this case user X, and then forms a set of nearest neighbors whose previous activities are similar to user X. Amazon uses collaborative filtering algorithms. It could be user-oriented or item-oriented, which Amazon uses for their famous customers who bought this item also bought that item. When it comes to a friendship recommender algorithm, Facebook is the leader in this field. Facebook uses their famous friends of friends approach, which obviously recommends friends of friends. The algorithm has a degree, which is the minimum number of the middle friends or common friends in order to suggest a friend of friend connection. The algorithm is very successful in terms of acceptance rate. So Facebook's friending algorithm, the friend-to-friend algorithm, is a very good friendship recommender algorithm, especially when it was compared to collaborative filtering algorithm and a content-based algorithm, because the friend-to-friend algorithm always recommends already known people, which are recommendations that are easily accepted. And in several studies, these recommendations were rated good by users. However, although these recommendations have a higher acceptance rate and most of the time rated good, it doesn't necessarily mean that they were actually a good recommendations, basically because most of these recommendations did not lead to any interactions. In 2007, and the date is important, a study was conducted in 2007 on 4 million records of Facebook users, and the study concluded that users interacted with only about 15% of declared friends. Another study in 2010 noted similar low interaction rate and reported that users within Facebook interact 80 times more with non-friends than with declared friends. In our data sets, which we collected in 2018 and 2019, the data set we collected in 2019 is not included in this paper. In both data sets, we noticed almost exactly the same low interaction rate. In 2007, Facebook only had about 100 million users, and in 2018 they have about 2 billion active users with almost exactly the same low interaction rate, probably because they have been using the friends of friends algorithm, which can only result with that much of low interaction rate. To test our algorithm against Facebook's friends of friends algorithm, we developed a web crawler that collects publicly available user profiles from Facebook. From each Facebook's user profile, we collected the user ID, gender, place, self-reported interest, which we earlier used for our exploratory algorithms, and we collected friends list, interactions. For each interaction, we We collect the post title, post ID, IDs for those who commented on the post, and IDs for those who liked that post. For anonymity, we replace the user IDs with randomly generated numeric numbers. This is our data set we collected in 2018, which is included in this paper. The seeds used to kickstart the collection process were randomly selected from parts of the UK and parts of the state of California and New York. We collected more than 16,000 users' profiles, unique user profiles, and the data set has more than 11 million interactions. As you can see from the graph, that the average percentage of users interacting with their declared friends is about 14%. So this is an example of a social graph. As we can see that the green painted users A, S, E, M are the common friends between X and user FOF, the friends of friends. As we can see, we have friendship connections, and the red ones are the interactive connections. Could be by comments and or likes. From the perspective of user X, the Facebook's algorithm is like, if many of my friends know user FOF, then I probably know user FOF. But in our algorithm, from the perspective of user X, it's like, if user FOF has interacted with many of my interactive friends, then I will probably interact with user FOF. So in simple words, our algorithm calculates the similarities between user X and user FOF in interacting with the same common friends. This is our algorithm. It takes user X and the social graph as arguments. Then in line 2 to line 5, we calculate the friends of friends list, the initial friends of friends list. Then in line 6 to line 7, we calculate the common friends. Line 8 to line 11, we calculate interactive common friends among those common friends. In line 12, we have our algorithm's threshold, which is the minimum number of common friends that both user X and user FOF have interacted with. This is similar to Facebook's algorithm's degree, which is in Facebook is the minimum number of common friends between user X and user FOF. Then based on our threshold, we update the initial friends of friends, and we only include the interactive friends of friends. To accurately validate the results of our experiment, we test our algorithm on recommending friends of friends who are already friends. This way we can validate the results by looking back at previous interactions that have occurred between user X and the respective FOF. For example, our algorithm only uses the blue connections and does not use or have access to the red connections. The red connections are only used for validations. Since both our algorithm and Facebook's algorithm recommend already known friends by recommending friends of friends, then they should both have a similar high acceptance rate. But we are measuring the accuracy of the algorithm as the percentage of recommending interactive connections. This is the algorithm's threshold performance. Remember, the threshold is the minimum number of interactive common friends between user X and FOF. When we increase the threshold, the accuracy of the algorithm increases, but the total number of recommendation decreases. As you can see, when we set the threshold to number 4, the algorithm was able to recommend 1,425 interactive connections and only 1,086 weak connections. This is the threshold we use in our experiment. So our IDF algorithm was able to find and detect 51% of all interactive connections within the dataset and recommend them, and also find 86% of all weak connections within the dataset and ignore them. So the accuracy of our algorithm is 57% in comparison to the friend of friend algorithm, which is 26%. So the percentage of weak connections recommended dropped from 74% to 43%. Before I end this presentation, I'd like to get your attention to our second paper in this topic. This paper was published in IEEE Access. In this paper, we presented another IDF algorithm which was focused on outgoing edges instead of incoming edges. The algorithm resulted in a higher accuracy than the fringe of fringe algorithm, but we noted that our two IDF algorithms resulted in different sets of interactive connections. So to maximize the results, we designed and implemented a k-means clustering algorithm that takes advantage of both of our IDF algorithms, and then resulted in a higher accuracy than both of our IDF algorithms. With this, I end my presentation. So thank you so much for listening.
Thanks for your presentation. Are there any questions? I have a quick question. So I think your new algorithm is very effective. How about computational complexity? Does it take more time to run or same time?
That's a very good question, but I don't think that would apply in that scenario, because time complexity is not an issue, because this would be recommended over time. So Facebook would do like a friend-to-friend algorithm, will calculate it over time. So we didn't pay attention to time complexity, or so we didn't calculate it.
I mean, somewhere it needs to be executed, am I right? I mean, so
Yeah.
there is some cost associated with it. So,
Yeah.
So might be you can consider
basically because Facebook only does only calculate common friends, the middle friends. So we have more computation, which is to calculate interactivity. So the time complexity definitely will be higher than the Facebook.
Okay. Thank you. Any other questions from anybody? Okay, so if not, we'll move to the, I think the final paper, I think the fifth paper in the session, titled A Cross-Layered Inference in Multi-Channel MAC of VANET. And it will be presented by Fadala.
Yes.
You will present live, or is it a video or?
Video. Can you present the video that I sent?
Yeah, I think the conference organizers will briefly introduce yourself, and then they will play the video.
I am a PhD student at University of Technology of Terroir, France. My research interest in vehicular ad hoc networks architecture.
Okay, thank you. So then the video can be played. May I request the conference organizer?
the video is not available. Can you share it yourself?
Yes, I can play the recorded one.
Yeah, please proceed. Please proceed.
Yes. Cross-layered interference in multi-channel mic of VANET. Author's name: Fadlallah Shbib, Jamal Haidar, Walid Fahas, Yes Khouki, and Rida Khatoon. Presentation plan. Introduction. Valid OSI model. MAC and network layer. Reactive routing protocol. Proposed model SIR protocol. Proposed model. Channel periodic update in the SIR protocol. Results and conclusion. Vehicular ad hoc networks, VANET, are considered as an efficient technology to deliver safety and comfort to drivers as well as passengers. In fact, accident can be avoided by 60% if drivers receive warning message in a half of a second before the accident. Type of communication in VANET: vehicle to vehicle and vehicle to infrastructure.
Excuse me, you are not sharing the video, you are showing just a window. Can you reshare it, please?
Excuse me?
We don't see the video. Can you stop the...
I don't hear you.
No, you can only the audio is coming, the video is not being played. So if you have a video, please play it in the video mode so the slides will show up.
Yes.
Are you hearing me?
Cross-layer interference channel like of VANET. Author's name: Fadlallah Shbib, Jamal Haidar, Walid Fahas, Yes Khouki, and Rida Khatoon. Presentation plan. Introduction. Valid OSI model. MAC and network layer. Reactive routing. Proposed model SIR protocol. Proposed model. Channel periodic update in the SIR protocol.
Excuse me,
Result.
can you hear me?
Yes, yes. Vehicular ad hoc.
When you want to share, you find a lot of sharing objects. That so you have to choose the video sharing button.
Yes, yes. Okay, okay.
Stop the sharing now.
Yes.
Or if you want to present it live, that is also okay. If you want to do that.
Yes,
You have
yes.
You have the slides, you can directly.
I think that it will be better to move to the next presentation, and I ask the participants to send to us the video, and we will share it from here.
But I think this is the last paper in the session, if I am correct. Is there another paper? Can you please double check? I think this is the last paper in the session.
If you want, I can present it live.
Yeah, I think go ahead. I think if it is, you can share
Yes.
your slides, that might be better and directly present live.
Yes. Okay. Can I start?
Yes, please share your slides and then.
Yes.
And then we can start.
It's okay now?
No, we still see the old. Yeah, now
Yes,
now
yes.
it's coming. Yes.
Yes.
Okay.
A cross-layered interference in multi-channel MAC of VANET. Presented by me, Fadlallah Shbib. Author's name, Jamal Haidar, Walid Fahas, Ilyas Khouchi, and Rida Khatoon. Presentation plan. Introduction, VANET OSI model, MAC network layer, reactive routing protocol, SIR protocol proposed model channel periodic update, results and conclusion. Vehicular ad hoc networks, VANET, are considered as an efficient technology to deliver safety and comfort to drivers as well as passengers. In fact, accident can be avoided by 60% if drivers receive warning message in a half of second before the accident. Type of communication, V2V and V2I, vehicle to vehicle and vehicle to infrastructure. VANET OSI model. It is a model for understanding and designing a network architecture that is flexible. The VANET OSI model is built of 5 ordered layers: physical layer, MAC layer, network layer, transport layer, and application layer. And the MAC layer depends on control channel and service channel, 1 control channel and 6 service channel. The control channel used for transmission of safety packets, while the service channel used to transmission of non-safety data packets. The network layer, the role of the network layer is to estimate path between source and destination. Reactive routing protocols are called on-demand routing protocols because the routing process starts by discovering path when a source needs to communicate with the destination. These protocols do not maintain routing information at the network nodes if there is no communication. The route request contains the source address, destination address, hop count, sequence number, and etc. Proposed model. The main objective of our work occurs in proposing a new routing protocols named SIR for VANET. In general, a new metric has been defined based on signal to interference evaluation on multi-channel MAC. We built a cross-layer approach on the first and second and third layer in order to manage the interference in VANET. In particular, we target to select different channels, 1 for each hop on the path, to take the overall SIR maximization for the connection between the source and destination. After that, we select a backup SIR in order to minimize the calculation after a period of time. Proposed model. In the proposed model, the equations used. First, equation 1, which indicates the SIR value on channel for a specific node M. The SIR value equal to power transmitted over the summation of the power received. Equation 2 presents the received power on a generic node due to the transmission of node G. Equation 3 illustrates the best path between source and destination. Equation 4 selects the maximum SIR value in its channel in our proposed model, source A need to send a packet to source D, to destination D. It uses the reactive routing protocol. So the source A sends a route request in order to its neighbors, and the neighbors send the route request until it reaches the destination. When the route request reach the destination will send a route replay. As we see in route replay 1, route replay 2, and route replay 3. Node C calculate the SIR in all the available channels and select the maximum one, which is 16. It compares with the threshold. It's greater than the sigma threshold. And after that, we select the backup, which is the maximum, which is the closest one to the maximum, which is 12. And node C select them, put the maximum SIR in the route replay and send it to the node B. Also node C and node H. While in node C, the maximum SIR is below the threshold, so we discard the route replay. So the route replay, so in this case, we have two route replay 1 and route replay 3. Node B also makes like node C, select the maximum SIR, but compare the maximum SIR with the maximum SIR send it from node C. Also node H, compare the maximum SIR of node G with the maximum one of node H, and send the SIR to the node A. Node A receives two maximum SIR. Maximum SIR sent from B equals 16, while the maximum SIR sent from G equal 18. So the node A maximize the overall SIR. So it sends the data packets from node A to G and H till it reach destination D. Channel update the process for each node after a periodic time T. First of all, we check the SIR max. If it is greater than the threshold, then the process will end here. Else, if not, we check the SIR backup. If it is greater than the threshold, we choose the backup channel related to the backup SIR and send a change request message to all the neighbors to inform them about the new SIR. Else, if the SIR backup is smaller than the sigma threshold, in this case, for each node N, neighbor to the current node calculate the power received. After that, for each current channel, calculate the SIR level. Choose the best channel related to the best SIR, and after that, we send a change request packet. Performance evaluation. The evaluation of our algorithm is analyzed according to different performance matrices: packet delivery ratio, throughput, and end-to-end delay. This quantities measurement is useful for assessing the performance of vehicular communication in the proposed protocol compared to the standard one. Performance evaluation. We use the network simulator NS 2.35, the traffic simulator SUMO, the wireless communication 802.11p, propagation model, frequency band 5.9 gigahertz, channel width 10 megahertz, and number of vehicles. In the simulation results, figure 1 shows a packet delivery ratio with respect to the number of nodes. In the proposed protocol SIR, with respect to the standard reactive routing protocol that use the route request and route replay. Figure 1 shows the packet that our proposed SIR performs better in all cases. When we increase the number of vehicles, the proposed SIR, the packet delivery ratio, and the proposed SIR will perform better in all cases. Figure 2 shows the throughput with respect to the number of vehicles. Figure 2 also shows that our proposed SIR protocol performs better in all cases with respect to the standard one. Figure 3 shows the end-to-end delay with respect to the number of vehicles. Our proposed protocol performs better in all cases than the standard one. While in figure 4, we compare the end-to-end delay with respect to the speed of vehicles with number of vehicles equal to 40. Figure 4 shows that our proposed protocol, when we increase the speed of vehicles, give a less delay than the standard one. Conclusion: the communication between vehicles will lead to be more efficient and secure by providing information about traffic and road condition to vehicle drivers. The results indicated that an improvement achieved in terms of end-to-end delay, packet delivery ratio, and throughput in the proposed SIR protocol. For future work, we plan to explore a predictive interference metric method to predict the SIR value at each transmission channel. Thank you for your attention.
Thanks for the presentation. Are there any questions?
Yes.
So you indicated, I have a quick question. So you indicated the future work. Have you started anything along that direction, or it's still in the
Yes,
thought
we
process?
started future work in order in our work. In this work, we calculate the SIR and on each available channel. While in the future work, we use a Markov chain in order to predict the SIR value on each available channel, to predict the SIR value in the future state.
Okay.
In order to reduce the calculation at each periodic time.
Okay. And if there are no other questions, I think this is the last paper. The other paper is a poster. Am I right? Is anybody presenting that? I'd like to check with the organizers.
Good morning, everybody.
Yeah.
My name is Khalid
Okay. Please present.
Ishnofi. I'm a PhD student at University Mohammed V in Rabat. Today, I'm going to present a paper titled Extraction of the PV module's parameters using combined analytical numerical methods. First, I want to present the content of this presentation. I will start by presenting the objective of this work, and then I will present an introduction. Later, I will develop the photovoltaic modeling, and after that I will present the simulation results. Of course, the presentation will end by a conclusion. The objective of this work is to extract the 5 unknown parameters of single-diode model, and in order to present an accurate modeling, a combination between analytical and numerical methods has been used. The proposed method has to be validated through comparison with previous work and with experimental data. Thus, the simulation must predict the behavior of the solar modules in different operating conditions. As you know, the consequences of global warming are more and more obvious and have spread to all continents, which can cause a wide range of impacts that will affect every life form on Earth. However, the expanding use of renewable energy will permit us to replace the polluted fossil energy by a clean energy and protect our planet. In fact, the photovoltaic energy is the most dominant type of renewable energy, in which the world demand grows year after year. That led researchers to develop various modeling of photovoltaic module in order to understand the behavior of the photovoltaic system and the different operating conditions, which permits the industry to optimize the solar module performance and maximize the yield. That makes the solar energy competitive with conventional energy sources. Several models of the PV modeling were suggested in the literature using different methods such as analytical and numerical methods. Unlike some previous model which reduced the number of the unknown parameters from 5 to 4 or even 3 and using numerical method or analytical method, which can compromise the accuracy of the modeling, this paper proposes a fast approach to determine 5 parameters of single diode by combining analytical and numerical methods. Before presenting the modeling based on single diode model, let's talk first about the single diode model. The photovoltaic module is an assemblage of solar cells connected in series. Each solar cell is represented by an electrical equivalent circuit called single diode model, as shown in the figure. Using Kirchhoff current law, the output current of solar cell can be represented by the equation 2, where the specification of each parameters is shown below. The analytical modeling is carried out by using a set of mathematical operations based on 3 characteristic points, which are open circuit voltage, short circuit current, and maximum power points at standard test condition. In the open circuit mode, the current is 0 and the voltage is equal to the open circuit voltage. Replacing these values in the last equation, the equation 3 is obtained. When the solar cell is short-circuited, the voltage is 0, where the current is equal to the short circuit current. Thus, the equation 4 is obtained. At the maximum power points, the current and the voltage delivered by the solar cell are maximum. Therefore, the equation 5 is obtained. At the maximum power point, the derivative of the power with respect to the voltage is 0, which can be expressed in the equation 6. Now, in order to eliminate the shunt resistance from equation 3, the equation 6 is introduced in the equation 3. Once again, in order to eliminate shunt resistance from equation 5, the equation 6 is introduced in the equation 5. Now the expression of the photocurrent has to be eliminated. Thus, we replace equation 7 and equation 8, which permits us to obtain the expression of the reverse current. Now, by combining the equation 7 and the equation 9 in order to eliminate the reverse current, the expression of the photocurrent is obtained. In order to obtain the expression of shunt resistance, the expression of the reverse current is replaced in the equation 6, where the expression of A and B are illustrated below. Now, in order to find the expression of the ideality factor, a set of combinations and approximations has been adopted. First, the photocurrent is eliminated from the equation 5 by combining the equation 5 and the equation 3. In order to facilitate the calculation, the last term is neglected. Once again, the photocurrent is eliminated by combining the equation 3 and the equation 4, We adopt these approximations and we replace the equation 14 into equation 13. And after reorganizing the obtained equation, the expression of the ideality factor is obtained. As you can see, the 5 parameters are expressed as function of series resistance. When their value is known, all the other parameters will be known. This flowchart summarizes the proposed approach. First, we input the datasheet parameters, which is open circuit voltage, short circuit current, maximum current, and maximum voltage. And then we solve the equation 2 with branch method using fsolve command in MATLAB. That gives us an initial value of all parameters, but for more accurate results, only the value of the ideality factor is kept, and the remaining parameters are identified using a fast iteration by adjusting the computed maximum power to the maximum power indicated in the datasheet. The previous extracted parameters are a standard test condition, and they are sensitive to the weather conditions, which means their value changes by changing the degree of temperature and the level of irradiance. When the temperature of solar module increases, the power output of the solar module will decrease. Also, when the irradiance decreases, the power output of the solar module will decrease. Therefore, in order to have an accurate modeling, the effects of different environmental conditions must be taken into account by using the following equation. The value of the photocurrent at any operation condition is obtained using the equation 16, where G is the irradiance and GSTC is irradiance at standard test condition, which means 1000 watts per square meter. T is the temperature and TSTC is the temperature at standard test condition, which means 25 degrees Celsius. Chi I is the short circuit current temperature coefficient of the solar cell. Each solar cell technology comes with a unique temperature coefficient. These temperature coefficients are important because the temperature of the solar cell has direct influence on the power output of the PV module, as mentioned before. The saturation current is affected by the temperature changing, as illustrated in the equation 17, where I is the ideality factor of the diode, T is the absolute temperature, Chi is the Boltzmann constant, and Q is the charge of an electron. Eg is the gap energy, and EgSTC is the gap energy at standard test conditions. The series resistance is affected by the temperature and irradiance, as mentioned in the equation 18, while the shunt resistance is assumed to increase as the solar irradiance decreases, as shown in the equation 18. And finally, the value of the gap energy is estimated using the equation 20. Regarding the ideality factor, it is considered that it has a negligible variation with the temperature and irradiance in this work. The first table illustrates a comparison of the analytic method with previous work using 4 parameters, which mean that the value of the ideality factor has been entered manually in order to adjust the parameters with the parameters of the other models. As you can notice, the analytical method presents an excellent corresponding with the popular model in the literature using PXP201 multicrystalline photovoltaic module. In addition, the table 2 shows the ability to extract the unknown parameter for different photovoltaic technology with good corresponding as well. In order to validate the proposed model through experimental data, the figure on top represents the computed curve with experimental EV data of CASI 200 GT at 25 degrees Celsius and difference irradiation level, figure A. While at figure B, the irradiance is fixed at 1000 watts per square meters and the temperature is varying. The obtained simulation shows good corresponding between theoretical and experimental curves. The figure below represents the absolute error, which is defined as the absolute difference between the experimental and the computed current for every voltage point of EV curves. Figure A shows the error due to the variation of irradiance, while figure B represents the error due to the variation of temperature. As you can see, the error is kept below 0.4 ampere even in high temperature, which affirms the reliability of the proposed model. Now let's talk about the summarization of the accuracy of the proposed model. The figure on top illustrates the absolute error of the proposed method with the results of Walker and Villalba at standard test conditions. The obtained results indicate that the computed absolute error are maintained below of the error of the model proposed by Walker and also by Villalba, which illustrates the reliability of the proposed model. While the figure below represents the root mean square error, RMSA, which summarizes the precision of the modeling. The computed results are less than 0.28 ampere even at high temperature, which confirms the accuracy of the model. Consequently, the proposed model is validated and can be used for various purposes. In this work, a combined analytical numerical method has been proposed to extract the 5 parameters of photovoltaic modules. The analytical method was developed based on the equations of 3 main points, which is open circuit voltage, short circuit current, and maximum power points. The obtained equation has solved with branch method in order to find the initial value of series resistance, while the numerical method was added in order to find the optimum value of RS. The extracted parameters have been compared to the previous model and for different photovoltaic technology. The results have shown good accuracy. In addition, the simulated and the experimental curves illustrate good correspondence. Furthermore, the comparison of the computing absolute error with previous method confirmed the validity of the proposed model. Therefore, the proposed model can be used for photovoltaic designer and for maximum power point tracking algorithms. I thank you for your attention and I will be very glad to hear your comments and answer your questions.
So is the speaker there? Are there any questions for the speaker? I think the author of the poster is not here, so we cannot have any QA. So I think that concludes this session. I'd like to again thank to all the speakers. I think we had a few technical issues, but those are expected these days in the Zoom context. So I'd like to again thanks all of you, and please enjoy the remaining part of the conference tomorrow.
Huh?
Any other announcements anybody would like to make? The conference organizer.
Okay, Dr. Panda. Do you hear me? Do you hear me?
Yeah.
Okay.
Yes,
so thank you very much, Dr. Panda, for your help, support. Donc, the author is it not happy to meet you in the next year?
Sure, sure.
So
So thanks for organizing this conference. It must have been a lot of challenge for all of you.
okay. Okay. Goodbye.
Bye.
Bye.